Okay, test 3 review. Find the derivative of the inverse sine of 3x. Okay, so the rule is you put u prime on top and 1 minus u squared and the square root on bottom, where u is the angle. So u is 3x, du is 3 dx. Okay, so dy dx, we can write dy dx and then not have the dx on the top. The derivative of 3x is 3, and u squared would be 3x squared. Okay, so that would be 9x squared. Okay. Number 2 is a product rule because we have two separate things. So we're going to take the derivative of 3x is 3, rewrite the inverse tangent, plus rewrite the 3x. Now we're going to take the derivative of tangent inverse. Okay, so we put u prime on top where u is the 2x. So derivative of 2x is 2. We put 1 plus u squared on bottom. So 2x times 2x is 4x squared. Okay, then on top we multiply 3x times 2 is 6x. Number 3, integral. When we have the square root of a squared minus u squared, where a is a number and u is a function of x. If a squared is 4, then a is 2. If u squared is 9x squared, u is 3x. And the derivative is 3. Okay, so we need the 3 on top, so we put a 1/3 because we need a du on top. So 3 dx will be our du. We've got a squared minus u squared. Okay, and the integral of this is arc sine of u over a. So that's going to be 1/3 arc sine of 3x is u over a is 2. Okay, number 4, 1 over x squared plus 1. That's going to be the form of du a squared plus u squared. Okay, now a is the number. A squared plus u squared is u squared plus a squared. So u is the x squared, a squared is the 1. So that means a is 1 and u is x. So we have the derivative of u is 1 dx. So we have du over u squared plus a squared is 1 over a, which is 1 over 1. Arctan u over a, which is x over 1. Okay, so that's just arctan of x. We're going to plug in arctan of the square root of 3 minus arctan of 0. Okay, the arctan of square root of 3 is pi over 3. The arctan of 0 is 0, so we get pi over 3. Okay, tangent is y over x. So if we had the square root of 3 over 2 divided by 1/2, we would get the square root of 3. So the tangent at pi over 3 is square root of 3. Okay, number 5, we have two separate functions, so we're going to use integration by parts. So the original problem needs to be split up into u and dv. Okay, u needs to get easier when you take the derivative. Okay, so the derivative of ln of x is 1 over x. That means 3x dx is our dv. Okay, dv means the derivative. To get v, we integrate. So we'd have 3x squared over 2 would be v. Okay, now our formula is we do u times v. Okay, u is ln of x, and v is 3x squared over 2, minus integrate v du. V is 3x squared over 2, and du is 1 over x dx. Okay, that first part stays the same. We're going to do a little algebra. X squared over x becomes x. Okay, we have x squared over x becomes x. First thing stays the same. Integrate x would be x squared over 2, and we times by the 3 over 2. And that second piece, 2 times 2 is 4. Okay, now we're going to integrate with parts again. Okay, e does not get any easier when you take the derivative. Okay, so that means it's going to be the dv. U is going to be the 2x. Okay, the original problem needs to be u dv. Okay, and then our formula is uv minus integral of v du. If u is 2x, du is 2, which means dv needs to be the e to the 5x. When you integrate e to the 5x, you get 1/5 e to the 5x. Okay, so now we're going to plug in uv. U is 2x. V is 1/5 e to the 5x minus V is 1/5 e to the 5x. Du is 2 dx. Okay, I'm just going to multiply that 2x times 1/5 in the front part. The integral part, 1/5 times 2 is the 2/5 out front. Okay, that first part stays the same. That second part, I need a 5 for the integral of e to the 5x. So a 1/5. 2/5 times 1/5 is 2 over 25. Now I have e to the u. The integral of e to the u is e to the u. Okay, and I'll rewrite u as 5x. Okay, and that's the end of the review.